Hey guys, in this video we are going to go over page 27, linear characteristics. So go ahead and add page 27 to your table of contents, and then I'll give you the half sheet that we're going to tape down on page 27. So characteristics of linear. So what we're going to do, we're going to look at these two examples, y equals 2x minus 3 and y equals negative 1/3 x plus 2. So we're going to do a little bit of a review of graphing these first. So we have y equals 2x minus 3. So we start at our y-intercept of negative 3. So I'm going to put 3 lines and go down here to negative 3. That's where we start. It's our b value. And then our slope is 2 over 1. So we're going to go up 2 and to the right 1 from that y-intercept. I'm going to put a couple more lines here. So up 2 over 1 gets me right here. And then up 2 more over 1 more gets me right there. And then I have enough points to draw my line. So we're going to review these characteristics. So increasing is where my graph is going up. So something that we notice is the graph is always going up because it has a positive slope. So if it's always going up, since it's positive, we say that it's increasing from negative infinity to positive infinity. And that's just the whole graph is always increasing. Now, it would be decreasing if the graph has a negative slope, but we can see that it's going up, so it's never actually decreasing. The graph is never going down. The next key feature that we have to review is end behavior. So end behavior talks about the arrows of the line. So this is the left arrow, and the left arrow is pointing down. And this is the right arrow, and the right arrow is pointing up. So we have this notation that we use for our end behavior. So as x approaches negative infinity, meaning the left arrow is pointing down, so f of x, which is just a fancy way of saying y, is also approaching negative infinity. So our end behavior we write out like this. It's a little bit different, and this is the first time seeing end behavior like that. So now we have another arrow. We have the right arrow. So as x approaches positive infinity, that's the right arrow, f of x is approaching positive infinity as well because the right arrow is pointing up. So that's the end behavior. If you need to review end behavior a little bit more, go ahead and pause the video. For now, we're going to look at zeros. So zeros are my x-intercepts. So that's something that we have to remember. So we're going to go up here and we're going to look for our x-intercept. So here's a point right here. It's where it crosses the x-axis. That is my x-intercept. And we can say that's about 1.5. So our x-intercept is the point 1.5, this is 1.5, comma 0. And that's the yellow point on my graph. So x-intercepts is just the point where it crosses the x-axis. We're going to skip over the domain and range for now. We have separate notes that we're going to use for domain and range. And then our max and min. So looking at this graph, the graph is always increasing. So there's not a highest number because that graph is going to go on forever. Same thing for the bottom, the graph is always going to go down forever. So there is no max and no min because it's infinite. So the arrows make it go on forever, meaning there are no max and mins. All right, so go ahead and pause the video if you need to go over any of those key features for the very first graph. We are going to go through all of those same features for another graph. So let's go ahead and review how to graph this. So we have our b value, that's where we start. So I'm going to go up to +2. That's where I'll put my first point. So that's my b value, that's +2. Then my slope tells me to go down 1 and to the right 3. So I'm going to, from this point, go down 1 and write 1, 2, 3. Now that I have 2 points, I can go ahead and draw my line. Okay. So next thing we're going to do is just go through each of the key features. So my graph is actually going down this time. It has a negative slope, which means my decreasing is actually the one that is from -infinity to +infinity, because it's always increasing or decreasing. Sorry, it is never increasing because it's never going up. It's always going down. Next thing is end behavior. So this is the left arrow and it's pointing up. This is the right arrow and it's pointing down. So we have that notation as x approaches -infinity. That's the left arrow. F of x approaches +infinity because the left arrow is pointing up. Now, the other arrow, x approaches +infinity. That's our right arrow. The right arrow is pointing down, so f of x is approaching -infinity. So really all we're doing is deciding if we're going to put in infinity or -infinity based on which way the arrow is pointing. Next thing is our x-intercept. So I have where my graph crosses the x-axis right here, so it looks like 1, 2, 3, 4, about 5, 0 is my x-intercept, or my 0. Remember, my 0 is my x-intercept. This is where the graph crosses the x-axis. We're going to skip the domain and range for now. And then just like the other graph, since our line keeps going on in both directions forever, it's infinite. So there is no max and no min because it keeps on going forever. Okay, so those are all of the features that we need to be able to identify if we're given the equation of the line or the graph of the line. So go ahead and pause the video and get page 27 all complete, and then I'll go ahead and give you the assignment that goes with this page.